height. Shows when a football is kicked, the nearest defensive player is 6 feet from the point of impact. The height of the punted ball is given by that equation there, where x of the ball's horizontal distance in feet from the point of impact foot. What's the maximum height of the punt, and how far from the point of impact does this occur? Okay, so what's the maximum height? So to do a maximizing problem, you're going to have to do this. X equals negative b divided by 2a. You're going to have to use that formula. So to do a maximizing problem, now you could visualize this on Desmos, but okay. So negative b is 1.18 over 2a. 2 is negative 0.01. That's going to give you the height. This is the distance of the point from impact. Distance of the point from impact. This is going to be your x. So negative 1.18 divided by 2 times negative 0.01. 59. So it's going to be 59 feet. Now that's your, how far from the point of impact? That's the point of impact. That's your x. So that's your point of impact. So that's point of impact. Okay. How do I find the maximum height now? What do you think I'm going to do? How do I find the maximum height? I plug in 59 into the function. So negative 0.01 times 59 squared plus 1.18 times 59 plus 2. If you did Desmos on this, it's kind of borderline cheating because Desmos will give you the vertex right off the bat. And it'll give you the critical points. Sometimes you need to look at the zeros. 36.81. That's feet. That's how high the ball will reach in the air. That's your max height. Oh boy. Get excited. We're not already excited. How far must the nearest defensive player who's 6 feet away from the point of impact reach the block punt? This 6 feet from the point of impact, is that an X or a Y value they're giving you? Is point of impact an X or a Y? It's an X. So they want X to be 6. You're just plugging in 6 for X. 6 squared. They usually do this as a function of its time. Projectile motion is a very common application of quadratics. I'm not saying you'll use it in the real world, but there is real world application to this. It's kind of looking at that. 0.18. Kind of more specialized. So 8.72 feet. He's got to reach. He's got to reach that far to be able to block it. Okay. So he's got to go reach that far up, which that's pretty, so you'd have to jump pretty good vertical there. Okay. If the ball is not blocked by the defensive player, how far does it go down the field before it hits the ground? Hits the ground means what's going to be what? What does it mean when it hits the ground? Good. What will be at 0? The height. Good. The Y. There you go. Good. So the Y will be 0. Who said that over there? Lauren? Yes. So the height's going to be at 0. Now this one kind of sucks because you're going to have to do quadratic formula. Now if you cheat on Desmos, Desmos would spit this out for you immediately. Because Desmos will like give you this point when you look at it. You could actually, I don't know if our graph, you could probably look at the, it's not going to be nice probably. But you're going to do, I'm going to do quadratic formula here, but if you cheated using Desmos, I guess you could do this faster. Yeah, that's a ways away there. So A equals negative 0.01, B equals 1.18, C equals 2. So you have to do quadratic formula. I'm I'm going to plug it in and I'll pause here. 1.18 squared minus 4, 2, all over 2a. Okay, I'm going to pause. I'm going to try to make this window fit this. So my x min 0, my x max, it's going to be 40 would be good. My y min 0, my y max, let's go 100. See if I can see this. Dang, it's more than 100. 100 feet, I guess. It's not yards, so let's go to window. Let's go try 300. It's still in the air. Look out. Well, L for me. 0.18. I'm going to type that square root in there, even if it's not nice. 1.18 squared minus 4 times negative 0.01 times 2. It'll be 1.21. And you make two separate ones. Negative 1.18 plus 1.21 minus 1.21 divided by negative 0.02. You're going to throw out one of these answers. Plus that divided by negative 0.02. So negative 1.67. Oh, got him. $119.67. And so the negative will throw out. And so we'll keep this. Okay. Jeez, it's taking forever. Holy. So it's going to take about around 120 feet for it to hit the ground. I promise you, your test is not going to be that bad. I'm scaring you a little bit today. They're going to cook on this test. Okay. All right, on the next part, the y-intercept is 2. How far does it go? How high does it go up? 36.81, so about 40. So I'll go 10, 20, 30, 40. And then it starts at 2. Its max height happens after 59. This has got to go all the way to 120. 20, 40, 60, 80. Dang it. Man. I'll do 20, 40, 60, 80, 100, 120. Oh, that's too crammed. Oh, well. So at 59 feet, it goes to 36.81. That's the highest it goes to. So it would look like that. And then it goes back down. It hits 0 at 119.67. So it hits 0 right here. So it looks something like this. And it goes down on the ground like that. That's not really a work of art. So this is your max at 59, 36.81. The y-intercept, 0.2, and then your 0 at the ground at 119.67, 0.